Hi, this is your host Swapnil Bhartia, and today we have with us Sumer Johal, Executive Director of AgStack, a new project under the Linux Foundation. Sumer, it's great to have you on the show.
Thank you, Swapnil. Very nice to be here.
Tell us a bit about what is AgStack all about. So let's start with the story of the project and foundation.
AgStack is a community project that's designed to build digital infrastructure for the entire global community involved in agriculture. We feel that the world of agriculture is going through a digital transformation and needs to go through a digital transformation, but that transformation really needs to benefit from a common, community contained, neutral, and trusted infrastructure that really enables the applications to both be created and be consumed, both with scale, lower friction, lower cost, and higher security and high accessibility. There's a huge proliferation of data sets from satellite and weather and soils, etc. There's a huge proliferation of all kinds of software frameworks. There's a huge proliferation of technology widgets. And what we're doing is taking all of this already existing proliferation of body of work which is relevant for agriculture and sewing it all together to create a common, free digital infrastructure so that people can create applications without the friction that is there today.
What are the areas that you will be focusing on? Because when we do look at this space, we talk about there are a lot of government policies are involved. There can be a lot of things to do with industries which do fertilization. Then you look at irrigation. Then you look at power, supply. Then you look at distribution. So many components are there. So what is going to be the focus of this project?
The first thing to realize is that we're building the infrastructure. We're building the road. So when we think about a lot of these different things, just like a road has different types of vehicles that can go from point A to point B, our infrastructure is going to serve the needs of many different stakeholders with a common infrastructure. But we also have a notion of this umbrella project at the Linux Foundation, which allows us to have sub-projects for specific topical areas that may require additional specialized tooling that is focused for those. So for example, we have one sub-project which is focused on crop nutrition and protection. So for that, we're building AgStack to have models and frameworks and data that can basically be served up to applications that may want to go after different areas within that sub-project. Another sub-area, which is totally different, is controlled environment agriculture, CEA. We're looking at frameworks like PubSub buses so that these controlled environments can actually publish and subscribe their data. Again, the road is very much common, but slightly specialized for these application stacks. We're not building the applications. We're going to be enabling the stack to create this common, pre-competitive part of the overall software stack that these applications have to use.
What is going to be the scope of the foundation? We look at all the Linux Foundation projects. It's all about software. Some are about specification also, like SPDF, but it's more or less about software. So can you also talk about in your pipeline, when we look at AgStack software stack, what it will look like? It's very early stage, but I'm pretty sure that you have a lot of things in the pipeline already.
Yes, so we are looking at software, but the software stack itself has, we think, sort of four core components. And let me talk to you briefly about those four core components. And so those four components are what we're going to be building. And these four components interoperate perfectly because they're going to be designed and maintained by us. So those four components, our first component is data. So as I mentioned earlier, there's a huge proliferation of data, satellite data, soils data, weather data alone, right? A lot of agriculture needs weather data. And essentially what we are going to do is to enable a common credentialed API to access these weather data sets that are available at a globe scale, such that people don't need to figure out how to download that data, how to make changes to the metrics, what does this metric mean, what does the metadata interpretation mean, whether it's imperial units or metric units. The translation and the amount of of work that people have to do to use these public data sets is too much because they're diverse. So just bringing weather data sets together with a common API, that alone, and then translated that to other data sets like soils and satellite, I think it's going to be transformative. So data is a big component of this, and just making that uniform access layer so you can give a time and a location, and you just get the data back with the metadata. The second part is going to be models. So we have a growing list of research institutions from the University of California and the Oates Center in Purdue University and the National Information Center for Agriculture Botany in the UK and many others that are coming to create a common repository of models that are searchable, that are indexed, that are usable. These are Python models that you can import simply with a single line of code. And these models will allow application developers to use scientifically created models to build applications on top of. And because we have a permissive license, the Apache 2.0 license, they can actually make a copy of that model and make modifications to that model in their own proprietary space if they so choose to do. But creating a common repository for models will not only help application developers, it'll also help researchers because they can see what other models exist. They can create new models. They can have a publishing place which is free for them to publish new models. And we'll publish usage statistics around those models so people can see which models are being used more than others. So that's the second piece of just models. And there are pest models, there are crop models, there are plant models, soil models, there are machine models, different tractors and models. There are lots of mathematical and numeric models that we will create in our Python repository. The third piece that we are building is essentially what we like to call frameworks. These are software frameworks, mostly open source, in fact, all open source, that already exist, but they exist in isolation. So we are using Django as a project. We're going to use some aspects of asynchronous message buses, for example. Those kinds of things that already exist, we're going to make sure they are interoperable and sewn tight with this data and models pieces that I just mentioned, and essentially can work so that people don't have to figure out how to install, how to run. There's a simple setup script, and it just works out of the box with the models and the data. That's the third component. And the last component, of course, last but not least, is what I call extensions and toolboxes. These are things that are required, for example, horizontally across sub-projects. Things like, the tagged image libraries, for example, for machine learning applications. So we'll create a repository where people can contribute tagged images. And these tagged images for plants, for insects, for diseases, for different types of equipment can be used to train machine learning models by the application developers such that these applications can take advantage of machine learning. Similarly, natural language processing, language translation, these are all utilities that already exist in open source. We're going to bundle them all in the toolboxes and extensions so that folks who are developing applications can use them out of the box. So those are the large four components which combine things. There's a lot more from IoT devices, connectivity, edge computing, access to different cloud networks. We are vendor agnostic, so we're not going to put one vendor or another, but this can run on any cloud, including people's own proprietary cloud. All of that stuff goes into extensions and toolboxes. So essentially, those four components complete what we are thinking about in terms of the overall design of AgStacl.
This is a project that, as you mentioned, they're going to involve so many players. So the community around AgSoft is going to be not only very vibrant, very rich, but kind of huge because you will have players from different walks of life. So can you talk about the ecosystem, what it's going to look like? What are the companies who are joining the foundation or the project from the very beginning?
We have cast a very broad net because we want to build the community as broad as possible to really be representative of how broad agriculture really is. Agriculture is a multi-trillion-dollar global economy and employs almost half of the world's population. It's the mother of all markets. And it's existential. We cannot live without food. And so essentially it's, I would say, the most important industry of all. and it's very, very large. So we really have to, we're starting a long journey. We really are trying to cast a wide net, and we want to be as inclusive as possible to not only cater to Western interests, but also cater to interests of developing economies, which in some ways may even be more important. We have representation from India, from the US, from Africa, from South America, and many of the companies that are joining that are global companies, but we have special interests in specific areas. We also have invitations out to people along the supply chain of agriculture. It's not just in the farming area, but input suppliers, fertilizer suppliers, crop protection management, equipment management, supply chain, logistics, transportation, packaging, labeling. Those are all aspects of agriculture which need a common, neutral, and trusted, stack, which is what AgStack is.
And some of the companies that you mentioned, they are already part of some other Linux Foundation project. And as you were earlier mentioning about building the whole stack software, how much are you standing on the shoulders of giants versus building things from scratch? What are the projects, communities that you will leverage for AgStack from the Linux Foundation ecosystem itself?
As I mentioned in our frameworks, a large part of the software pieces that we are going to be using to build the AgStack will be existing open source projects, like Kubernetes, for example, that already exist in the Linux Foundation, and we could easily take it, sew it together, make some custom tailor it, and it's all open source. So we need to modify it for our purpose. We can do so without any, problems. And I think that's the beauty of being part of an ecosystem where there are other innovators that are already doing a lot of the pieces, and we just need to sort of tailor those pieces to our use.
Sumer, thank you so much for taking time out today. And I'm excited myself to see how this project evolves over time. So thanks for your time. And I will, of course, keep an eye on the project. I look forward to talk to you again. Thank you.
Thank you, Swapnil. Look, we're very excited about creating this big community around agriculture tech stack, AgStack, at the Linux Foundation. And since it is a community, I'd like to invite all your viewers to consider joining, contributing, maintaining any which way that you can come and help us grow this community, make it better so that the future of our food, the future of our civilization, in no matter which country, no matter which language, no matter what culture you come from, we all need to eat. We need to survive, and this is going to go a long way towards making that more efficient, healthier supply chain, and more profitable for all stakeholders. So, inviting all members to come and reach out, and if they're interested, come join us to build this community.